Dear students, welcome back to our discussion. So, in the last session, we discussed how we can think of methods to improve the COP of the vapor compression refrigeration systems, that is VCRS. So, one such system we have discussed in the last class was subcooling. So, how we can bring about the subcooling of this refrigerant using a cooling water circuit. That was what we discussed in the last class. So now let us discuss somewhat a different kind. Here also we are discussing subcooling of liquid refrigerant using the vapor refrigerant itself. That is, we are subcooling the refrigerant using the same refrigerant, but we are subcooling the liquid form of the refrigerant using the vapor form of the refrigerant. So how we can bring about that situation. So now let us look at this diagram. So this is the arrangement for this subcooling, for achieving this subcooling of liquid refrigerant using vapor refrigerant. So here we are having the same parts that we learned in the case of standard VCRS. That is the evaporator. There is a evaporator followed by a compressor, followed by a condenser, and there is a expansion valve also. But here the only difference between this arrangement and the standard VCRS is that here, as you might be observing, here we are having an additional heat exchanger over here. Okay, so what is the purpose? What is the purpose of this heat exchanger? Let us look at that. So here. So now let us start with the most important portion of this arrangement, that is the evaporator or our refrigerator, okay, or the freezer compartment. What is happening at the evaporator? So here we are having an expansion valve just before this evaporator. So the refrigerant which is coming out of the expansion valve will be a low temperature and low pressure liquid refrigerant. Okay, so the refrigerant, the nature of the refrigerant coming out of this expansion valve will be a liquid refrigerant, but at the same time its temperature and pressure will be both very low. It is this very low pressure, low temperature liquid refrigerant which is going to enter our evaporator. So at the evaporator we will be keeping various heating loads, for example ice cream or vegetables, etc. From all these from all these refrigeration loads, our liquid refrigerant will be absorbing heat from these various cooling loads kept at the evaporator, and by absorbing that heat, this liquid form of this refrigerant will be slowly getting converted to vapor form of the refrigerant. Okay, and it is this vapor form of this refrigerant which is coming out of this evaporator through 1-. So what will be the nature of this refrigerant at 1-, that is after exiting from the evaporator? That is, it will be again it will be again remaining at a very low temperature and low pressure, but at the same time the nature of the refrigerant will be in vapor form. Okay, so the vapor form of the refrigerant which is at low temperature and low pressure, it is coming out from the evaporator through 1-. So after coming out from 1-, it is not straight away going to the compressor, just like in our standard VCRS. But in difference to the standard VCRS, here this low temperature and low pressure vapor form of this refrigerant which is coming out from 1-, it is going to enter a heat exchanger. So what is happening at this heat exchanger? That is mentioned over here. So here at this heat exchanger, what is happening? The vapor form of the refrigerant, that is just we mentioned here at 1-, which is at low temperature and low pressure, coming out of this evaporator, it is going to absorb heat from where? It is going to absorb heat from the liquid refrigerant at very high temperature and high pressure coming out of this condenser. So here you can see this low temperature and low pressure vapor form of this refrigerant, it is passing through 1 dash and entering inside the heat exchanger. So what is happening here? At this heat exchanger, another flow is happening. What is that? A flow of liquid refrigerant coming out from the condenser. So what is the nature of the liquid refrigerant coming out from the condenser? It will be at a high temperature and high pressure. Why? Because after this compressor work, or after this isentropic compression process, the nature of the refrigerant will be in a superheated compressed state, superheated vapor form state. It will be in a superheated vapor state. It is this superheated vapor form which is condensing inside the condenser. So when the after condensation, the superheated vapor form will be converted to a liquid form of the refrigerant. But here at this condenser, no pressure is getting reduced. So the liquid refrigerant which is coming out of the condenser, it will be at a somewhat high temperature also, and it will be at a very high pressure also. So it is this high pressure, high temperature liquid refrigerant which is flowing from 3 dash and entering the heat exchanger and passing on to moving on to the expansion valve at 3. Okay, so this high temperature, high pressure liquid refrigerant which is flowing from 3 dash to 3 and passing through the heat exchanger can very well reject the heat to the vapor form of this refrigerant, which is at a very low pressure and low temperature, coming out from 1 dash and moving on towards the heat exchanger. Okay, so what is happening here? The vapor form of this refrigerant is absorbing heat from the liquid form of the refrigerant. Okay, so in such a case, this subcooling of liquid refrigerant using vapor refrigerant will be taking place. So here, why this subcooling effect is coming? Because at this condenser, at this main condenser itself, there is a large amount of cooling happening to the superheated vapor form of this refrigerant. But in addition to this cooling, again this liquid refrigerant is getting cooled, or its heat is getting absorbed by the vapor form of this refrigerant at this heat exchanger. Okay, in such an action, this subcooling effect happens for this liquid refrigerant passing or exiting from the condenser and passing through this heat exchanger and moving on to the expansion valve. Okay, so that is why this heading is given. This liquid refrigerant coming out from the condenser, okay, it is going to it is getting subcooled at this heat exchanger. Why? It is going to reject its high heat towards or onto the low temperature, low pressure vapor refrigerant, which is in a way coming out from the evaporator. Okay, so this heat exchanger is also called as liquid suction heat exchanger. So here, what does that mean? The liquid form of this refrigerant is rejecting heat or getting subcooled by the vapor form of this refrigerant. So now let us try to represent this concept in a meaningful thermodynamic diagram. So now let us try to represent this in the TS diagram. So first let us focus on to our evaporator or the refrigeration effect. Okay, 4 to 1 dash will be our 4 to 1 dash. It will be our constant pressure heat absorption step. So here what is happening during 4 to 1? The liquid refrigerant, okay, coming out from this expansion valve at 4. Okay, the liquid refrigerant coming out from this expansion valve at 4, it is going to enter the evaporator and absorbs heat during a constant pressure process. Okay, and at 1 dash, the nature of this refrigerant will be saturated vapor form. Okay, so that is point 1 dash represents the delivery or the exit from the evaporator. So again, what is happening? the refrigerant, the liquid refrigerant, the vapor refrigerant coming out from 1 dash, it is going to the heat exchanger where it is absorbing heat from the liquid refrigerant. So again, at this heat exchanger, there is no pressure changing equipments, or there is no pressure changing phenomenon happening at the exchanger. So this 4 to 1 dash, it was already at a constant pressure process. So 1 dash to 1 also will be a constant pressure process. So 4 1 dash 1, it will be a constant pressure line. 4 1 dash 1, it will be a constant pressure line. So it is this saturated vapor form of this refrigerant getting heated or getting or absorbing heat from the liquid refrigerant. Okay, so this vapor form of this refrigerant will be getting superheated. That is why we will be marking 0.1 in the superheated vapor region. Okay, so then after this process, from 1 to 2, it is our isentropic compression process. The main compressor working, that is isentropic compression process 1 to 2, that is represented over here. Okay, then the remaining process are same. 2 to 3 dash. 2 to 3 dash, it is our constant pressure heat rejection process or condensation process happening at the main condenser. So 2 to 2 dash, first of all, the superheated vapor form is converted to the saturated vapor form of this refrigerant. Then again at the condenser, it is again rejecting heat. So along the constant pressure line 2 dash 3 dash, 2 dash 3 dash is a constant pressure line which is happening inside the condenser. Okay, so after this coming out of this condenser, main condenser at 3 dash, the nature of the refrigerant will be saturated liquid. But what is happening to the saturated liquid at 3 dash? It is again going inside a heat exchanger, and where it is again rejecting the its high heat towards a vapor form of this refrigerant coming out from the evaporator. So what is happening to that liquid refrigerant? It is again getting subcooled. But here also in this heat exchanger, there is no pressure change happening or pressure reduction happening. So it will be again this heat exchanger is it will be working there is no pressure change happening to the liquid refrigerant coming out from the condenser. So the constant pressure line 2 dash 3 dash, we can extend it downwards, and we can mark a 0.3, where 0.3 represents a subcooled it will be representing a subcooled region where this liquid refrigerant will be remaining after it is coming out from the heat exchanger. So 3 dash to 3 here, it is representing the subcooling phenomenon happening to the liquid refrigerant when it is passing through the heat exchanger. So again from 3 to 4, the remaining portion is the 3 to 4, it is our isenthalpic expansion process or expansion valve, the throttling valve 3 to 4 here. Okay, so the same thing happens over in the pH diagram also. 4 to 1 dash will be our normal evaporator process. 1 dash to 1, the refrigerant is getting superheated. Then 1 to 2, it is our isentropic compression process, followed by the main condenser working 2 dash 3 dash, and also 3 dash to 3, it is the subcooling effect happening to the liquid refrigerant. Then followed by 3 to 4, that is our throttling valve or isenthalpic expansion process, followed by the evaporator process. So here what is happening? The heat rejected by the liquid refrigerant during 3 dash to 3, some heat is getting rejected from the liquid refrigerant during 3 dash to 3. It is the same heat. This same heat is gained by the vapor refrigerant during 1 dash to 1. Or we can, in another words, we can say that the superheating of this vapor form of the refrigerant during 1 dash to 1 is supplied by the heat rejected during 3 dash to 3. Okay, so with this, let us continue later.